Hello and welcome to our mathematics lesson. Today we are making an introduction into a new topic on properties of geometrical figures. There are a number of subtopics which we are going to cover in this particular topic. One of them is about the angles and triangles. So we're going to look about to look at angles and triangles, which you can be able to recall that triangles are three-sided figures. Number two, on the same topic, we are going to look at parallel lines, where we shall now discuss and look at what parallel lines are. Number three, we shall look at quadrilaterals and other polygons. Where we do understand that when we mention about quadrilaterals, it's being derived from the word quad, meaning four. So these are four-sided figures, and we shall also be looking at other polygons which have got more than four sides. Like when we talk about at a five-sided polygon, that is a pentagon. If you talk about a six-sided polygon, that is a hexagon, and so forth. Number four, we shall cover something on congruent triangles. Here we shall majorly be dealing with the congruency of triangles. When can we say one triangle is equivalent to another triangle, and in what ratio can we be able to express one triangle in terms of the other? Number five, we'll also be touching on concurrency of triangles, and we shall be seeking to establish, using concurrency, in solving problems involving triangles. And this will simply be the proof of concurrency in giving solutions to problems pertaining triangles. Number six, we shall look at enlargement and similar figures. Where we shall be seeking now to learn how or what factors can we be able to use to enlarge certain figures, and if they are enlarged, when do we say figure A is similar with figure B? Second last, we shall look at similar triangles. And under this particular subtopic, we shall make good use of the proof that we had originally learned on the congruency of those particular triangles. Then lastly, we shall be proving and applying similarity of triangles. So these are the 8 subtopics which we are going to cover across this particular topic on properties of geometrical figures. We are going to, during this particular lesson, we are going to look at the first two, that is the angles and triangles, and also touch on the parallel lines. So first we're going to cover on angles and triangles. Now at this juncture, it is important for us to understand how do these particular plane figures, how do these angles originate or come about. When we were discussing about the length, perimeters and circumferences, we did say that the length is the difference between two particular points, and it gives what we call a line. So a line is a straight section joining two particular points. And we did say that whenever we join more than one line at one point of intersection, it forms what we refer to as an angle. So this particular figure here, or the line, the two lines are giving us or forming an angle of size theta degrees. So I would like to make commencement on that. Then this topic is very important, as its application runs in so many sectors and areas. At one point, these properties of certain figures can be used to create things that are practically impossible. What we call them simply illusions, or things which you cannot be able to achieve in the real time or in the real situation. Like Penrose one time developed what we call the Penrose Stairs by using a combination of a 2D triangles. And in that particular Penrose Stairs, you can be able to actually appreciate the work that he did, but you can never achieve such a Penrose stair in the real sense. It's an endless staircase where you climb from one particular end and you can never reach the end. You will find yourself at the same point, but you keep on climbing. So practically it is impossible to achieve that, but theoretically, or you can be able to create it by illusion. This topic is used there. So the first point we note concerning angles and triangles is that when two rays whenever we have two rays of light, lines, it can be a full line or a segment of a line, or line segments meet at a point. Whenever we have them meeting at a point, they form an angle. That is what I was trying to demonstrate using the two lines, line AB and line CD. When they intersect at a particular point, they form an angle at that particular point. Now, assuming we had a line AB meeting with another line BC, they will form an angle theta there. This angle is normally denoted using that particular sign, and for you to name this angle here, you can be able to see it's at B. So you can either go ABC or CBA. So this particular angle formed is called angle ABC. B, where that particular angle is, should be in the center, or when we come from this other particular side, this ray B, CB, that shall be angle CBA. Again, B is at the center of the two. Now, when this angle is formed, it can be less than 90, it can be more than 90 degrees, it can be less than 180 degrees, it can be less than 360 degrees. So given, depending on its size, we have different names for different angles. Now, depending on the size of that particular angle that is formed by either the two rays, the lines, or a segments of a line, we might have different types of angles formed. The first and the most common type of an angle that will be formed is what we call an acute angle. Now, acute angles are usually more than 0 degrees, but less than 90 degrees. So it is between 0 degrees and 90 degrees when measured. That means it is, if that is our angle theta, then it should be strictly less than 90 degrees, but greater than 0 degrees. So any angle you measure and you find that it is less than 90, that angle is an acute angle. Number 2 is now that one that is more than 90, but less than 180 degrees. It's referred to as an obtuse angle. And we are saying that an obtuse angle is between 90 degrees and 180 degrees. That is, if measured, that angle theta should strictly be less than 180 degrees, but more than 90 degrees. We have a third angle called the right angle. And for a right angle, it strictly measures 90 degrees. And we normally use a pair of perpendicular lines with a triangle like that to insinuate that this particular angle is a right angle. We have straight angle, which you can be able to say is an angle formed on a straight line, and it usually measures 180 degrees. So if that was our line, then we have this angle A and this angle B, then the whole of these angles will be referred to as angles on a line, and therefore they are called straight angles. And when you take A and B, the result, when you sum them, will be 180 degrees. We have a reflex angle. Now, a reflex angle is between, or measures between 180 degrees and 360 degrees. That means for it to be a reflex angle, it should be strictly less than 360 degrees, but more than 180 degrees. So it forms, or it gives, what you call a reflex angle. Then we have a revolution. Revolution means you go round something, and when you go round a figure, then you'll have covered a total of 360 degrees. (360 degrees). So these are the 6 main types of angles that we have. At some point, we might have what we call angles at a given point. Let us look at how for them they behave. Now for angles at a particular point, we have 4 of them. Number 1 is what we term as complementary. Complementary angles. Complementary angles are angles which, when summed up, will add up to 90 degrees. So given that we might have such, where we understand that this is 90 degrees, then the angle is subdivided into 2, and we are told that this is 60 degrees and this is 8 degrees. So for complementary angles normally add up to 90 degrees. And therefore, if you know this, then for you to be able to get the value of A, then you sum up 60 plus A to give you a total of 90 degrees. You collect the like terms together. A will be equal to 90 degrees minus 60 degrees, and therefore A will be equal to 30 degrees. So that is for the case of complementary angles. Number B, we have supplementary angles. Now supplementary angles normally sum up to a straight angle or 180 degrees. So that in the case you have a straight line, then we have this particular point here. So these are angles at a point. Let this be 8 degrees and this other one be 98 degrees. Then for you to be able to find the value of A, we use the component of supplementary angles, where these 2 angles are supposed to give us a straight angle, which is 180 degrees. So when you group the like terms together, that will be 180 degrees minus 98 degrees, and that will tell you that A will be 82 degrees. So this is the case for supplementary angles. So supplementary, they add up to 180 degrees, and for complementary, they add up to 90 degrees. Number C, is about a revolution. Revolution are also angles at a point. So given we have this particular point, we have converging of those particular lines, which is forming an angle here. I don't want to say what angle is that. Then this is angle A, and this is 115 degrees. Now we understand that for a revolution, the sum of those angles should be equivalent to 360 degrees. So that for us to be able to find the value of A, we need to equate these angles that we have been given here to 360 degrees. You'll be able to recall this when we use this symbol. We use this symbol whenever we want to say that this particular angle is what? Is a right angle. And therefore, for us to be able to get the value of A, you take that A plus 90 degrees plus 115 degrees. The result should be a total revolution, which is 360 degrees. 90 plus 115 will give us 205, which is equals to 360 degrees. Then, of course, we find this is plus. We group the like terms together. That will be 360 subtract 205, which will give us 55 degrees. And this will tell us that our missing angle there is 55 degrees. Lastly, part D of the angles at a point are vertically opposite angles. Now for vertically opposite angles, these angles are usually equal angles. So in case we have two lines as that, then we are told that this is 130 degrees, this is 130 degrees, then you can be able to find the missing angle, since this particular angle given A will also be equal to the other side, which is A. And this one we are referring to them as vertically opposite angles. And therefore, you to be able to find that value, again we shall use the total angles at a point, which is a revolution. But now here we shall be able to take it as 2A plus twice 130, which will give us 260 to be equal to 360 degrees. Now when you group the like terms together and take 260 to the other side, we shall have 2A degrees to be equal to 100 degrees. And therefore, for us to be able to get A, we divide both sides by 2, which will give us 50 degrees. So this tells us that our value of A is 50 degrees. So they are vertically opposite in the sense that it's forming, the two are forming an X, and opposite sides, opposite angles in an X are referred to as vertically opposite. And vertically opposite angles are usually equal in nature. We now want to proceed on and now look at triangles. But maybe before we reach there on angles, we have said we have the four main: complementary, they add up to 90 degrees, supplementary, they add up to 180 degrees. We have looked at angles at a point, that is a revolution. And we have said all the angles add up to 360 degrees. And then finally, we have looked at vertically opposite angles, which we have said they are equal in nature. Now on triangles, triangles are normally three-sided figure. That is, they have got three sides which you can be able to measure. Now depending on the measurements of those particular three sides and the angles they contain, we can have three major types of triangles which can each be divided into two parts. So I want us to develop a table for that. Now depending on the angle, we can have acute angled, acute angled triangles, And in this case, all angles are acute. That means they are less than 90 degrees. And for this particular case, we have two types of triangles. One, in fact there are three. One is called a scalene. A scalene. A scalene triangle in which all the sides and all the angles are not equal. So if we can just try to demonstrate about a scalene, we can be able to say that this angle is not equal to this one, is not equal to this other angle. So that, or this particular triangle is called a scalene triangle. We have another type of an acute angle triangle which falls on the sides. So we can have one which is an equilateral, and two, an isosceles triangle. For the equilateral triangle, all the sides, all the angles are equal and they are less than 90 degrees. Like for example, it can be 60 degrees by 60 degrees by 60 degrees. All those angles are less than 90 degrees. Then we have got an isosceles triangle which has got two equal sides. That means the base angles are going to be equal. But again on the same, all the base angles are not more than 90 degrees. That is, they are less than 90 degrees. Then that qualifies it to be an isosceles triangle. So acute angle triangles, we have a scalene, we have an equilateral, we have an isosceles. Right angle, we have right angle triangles, and for these right angle triangles, it includes one angle which is 90 degrees. It includes a 90 degree angle. And of this type, there are two. One, we can have a scalene, and this scalene triangle, actually one of the angle is 90 degrees, but the other two are not equal. Maybe this is 47, the other one will be 42. So you'll discover that they are not, all the angles are not equal, and therefore all the sides are not going to be equal, therefore it's referred to as a scalene. Number two, it can be an isosceles triangle. It can be an isosceles triangle, but in this case, one of the angle is 90 degrees, then the other two are 45 degrees each. That means this side and this side are equal, forming these two as the base angles of that particular triangle. So right angle triangles, we have a scalene, and we have got an isosceles triangle. The last category is on obtuse angle. Obtuse angle triangles. For the obtuse angle triangle, one angle is greater than 90 degrees. And in this case, we have two types of triangles. One of them is a scalene. So for a scalene, we can have one angle which is more than 90 degrees, then the other two angles which are not equal. Then 2, we can have an isosceles triangle, in which case one of the angle is going to be more than 90 degrees. Let's say that is more than 90 degrees, but this and this sides are equal, meaning that the two angles are going to be equal. So those are the different types of triangles which can be formed depending on the sizes of their angles. But in an nutshell, this summarizes or brings down to only 3 types of triangles which are available. 1, we have a scalene triangle. 2, where, and with the scalene triangle, all the sides and all the angles are not equal. We have a right angled triangle in which one of the angle is 90 degrees. Then we have got an isosceles triangle in which 2 sides and 2 angles are equal. And finally, the 4th, we have what we call an equilateral triangle in which all the angles and all the sides are going to be equal. Another important aspect on the same triangles is on angles, that the sum of angles in a triangle add up to 180 degrees. And then an important thing is on the exterior angle of an angle. An exterior angle can be obtained, can be formed by extending one side of a shape. We are saying of a shape because it can be a triangle, it can be a quadrilateral, it can be any polygon. And for such, if we had a triangle ABC and we want to form exterior angles, then if you want exterior angles on this side, what you do, you just simply extend that side. This will be the interior angle and this one will be the exterior angle. Understand that in this case, interior angle and exterior angle lies on a straight line, forming a straight angle which is 180 degrees. And it can be formed in where you can extend this to form an exterior angle, you can extend this to form an exterior angle, you can extend this to form depending on where you want the exterior angle to be. Then we have something called the exterior angle theorem. And in this theorem, it normally states that the size of one exterior angle is equivalent to the sum of the opposite interior angles. That is exterior of a triangle is equivalent to sum of opposite interior angles. So that if you had a triangle with this side measuring A, that measuring B, then you have an exterior angle C. This exterior angle C is opposite to these two interior angles, and therefore C will be equal to the sum of the two A plus B. This is what we are referring to as the exterior angle theorem. We want to look at examples on how we can be able to solve problems that involves angles and triangles. For the angle, for 7 degrees, determine 1 supplementary angle, determine 1 supplementary angle, and 2 complementary angle. So from our previous discussion, we had talked about supplementary and complementary angles, plus and including the angles at a point, that is a revolution, and vertically opposite angles, where we said for supplementary angles, these are angles that total up or add up to 180 degrees. And therefore, if already you have 47 degrees, that means for you to get the other angle that will supplement it, you must less the 47 degrees from 180 degrees. Or if you take that supplement plus 47, you must get 180 degrees. So solution to this, when you take 180 degrees, we subtract 47 degrees, which will give us 133 degrees. So 133 is a supplement to angle 47. Then for complementary angles, we say that these are angles which measure or add up to 90 degrees or right angles. And therefore, if already you have 47, that means for you to get the other angle, you subtract 47 from 90 degrees, and this will leave you with 43 degrees. So when you take 43 degrees plus 47 degrees, you end up with 90 degrees, which is a right angle. Example 2, name the types of triangles shown and determine the value of the pronumeral. We have the first set of triangle. Here we are told that this is 60 degrees and this is 60 degrees. Then this one is x degrees. Number B, we have such a triangle where we are told that this is 120 degrees and that side is equal to that. Then the last one, number C, we have a triangle for which this side is not equal to that, is not equal to this, and we are told that this is 50 degrees, this is 60 degrees, and then this is S degrees. We are told that this angle here is R degrees. Now from our previous and from the table we drew when we were trying to name the different types of triangles that we have, it is clear that you can be able to mention which types these triangles are without even finding the missing angle. Now for the first case, you already see that this is 60 degrees, this is 60 degrees. This will tell you that first, this is an acute angled triangle where all the angles are going to be less than 90. And therefore it falls on either of the three categories. It can be an isosceles triangle, 2, it can be a scalene triangle, or it can be an equilateral triangle. And because already the two sides are equal and it is 60 degrees, that will automatically tell you that this will be an equilateral triangle. Now, in finding the missing part, we were told that angles in a triangle add up to 180 degrees. Therefore, if you take x plus 60 plus 60, you must get 180 degrees. And that means that x will be equal to the total angles of a triangle minus the two which you have been given, which is 120. And that will tell us that our x is going to be 60 degrees. And that will tell us that all these sides are going to be equal. Number B, two sides are equal. That means the base angles are also going to be equal. So if this is R, also this is R. What is the name given or ascribed to a triangle which has two sides equal and the base angles equal? It's referred to as an isosceles triangle. So this is an isosceles triangle where we said two sides are equal and therefore two angles are equal. And again, given that this will be under a triangle, then when you sum up all these angles, you must get 180 degrees. So when you take R plus 120, you get 180. R plus R will give us 2R degrees plus 120 will give us 180. So this means 2R will be equal to 180 minus 120, which will be 60 degrees, and therefore R will be equal to 30 degrees. So this is 30 degrees, this is 30 degrees. So we have solved or found the value of that particular pronumeral. Now for the third part, you can be able to see all the sides are not equal. This is not equal to this, not equal to that. That means that this falls under a category of triangles called the scalene triangles. And this side is 50, this is 60, and that is S. So for us to be able to get the value of S, we subtract the 2 from 100 S, and this will give us that S is 70 degrees. So you clearly see that all the angles are not similar or they are not equal. We now want to move to the other part on parallel the second subtopic, which is on parallel lines. Now, whenever we mention about parallel lines, we are talking about lines that can never, ever meet. And those particular lines should be as straight as possible. Then we have got another line that normally crosses those particular parallel lines. We refer to that particular line as a transversal. So we are saying we can have lines that if drawn and extended, they will never meet at any particular point. So such lines are what we refer to them as parallel lines, and we normally denote by using this arrow to show that they can never meet. And we normally use these two strokes to show that these two particular lines are parallel. So given line AB and CD, and you want to say that they are parallel, then we'll talk about AB being parallel to line CD. We have talked of a transversal. Let me call it EF. This particular line EF is referred to as a transversal. And as it cuts across these two parallel lines, it end up forming some particular angles. As you can be able to see, we have this angle formed, 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 and the other angle formed. Now these angles that are formed by the transversal and the parallel lines have got different names. So let me call this angle A, B, C, D, E, F, G, H. So a transversal creates all those angles. Number one is a set of corresponding angles. Now corresponding angles will always be equal for the case of parallel lines and a transversal. A good pair of corresponding angles in this case is angle C and angle H. Angle C and angle H are pair of corresponding angles. You can name others. We have D and G. We can have A and E. We can have B and F. You can name as many angles which are corresponding to one another. Number two is about alternate angles. And these are angles which will always be equal. So in this case, we can be able to mention, if this is the transversal and these are the two parallel lines, then these are what we refer to as alternate. C is alternating to F, also D is alternating to E. So they are equal. And an example, C and F, angle C and F, and also D and E. They are called alternating angles. Then the last type of angles formed by the parallel lines and a transversal is what we refer as the co-interior angles. Again, for the co-interior angles, they are usually supplementary. Supplementary means they form 180 degrees. Now, a good example of supplementary angles are these ones which are inside. They can also be corresponding angles, but the good example is these ones which are inside. So e.g. C and E, and also D and F. They form co-interior angles which are supplementary in nature. Let's look at an example on how we can be able to use these three particular angles to answer a problem connecting parallel lines and a transversal. Example, find the value of each. Find the value of each of the pronumerals. Find the value of each of the pronumerals. Number one, we have this set of parallel lines. We'd say that you'll see the parallelism by the indication of that. Then we have the transversal. This one is 110, that is A degrees, and this is B degrees. Then part B, we still have a pair of parallel lines. Then we have a transversal. This angle formed is 69 degrees. This is A degrees, and that is B degrees. So we want to find the value of these pronumerals. Now, for the first case, you can be able to see that this angle and this angle are vertically opposite angles. And for vertically opposite angles, or what we are referring to as alternate angles, they are usually equal. Therefore, A degrees will be equal to 110 degrees. Now, for us to be able to find the value of B, these two angles are co-interior angles, which we said are supplementary in nature. So if you take 110 plus B, you must get 180. That means that B will be 180 minus 110, meaning that B will be 70 degrees. And you can be able to fill all the other angles as it might be required. For part B, these are alternate angles, therefore this is going to be 69 degrees. Again, this angle and this angle are alternating, or they are vertically opposite, and in that case, not vertically opposite, they are alternate angles, and therefore if this is 69 degrees, B is going to be 69 degrees. Reason we are saying, the reason given there is that they are alternate angles. Then for us to be able to get A, these ones are forming a straight angle, and if you take A plus B, you will get 180 degrees. We already have B as 69, so that means that A will be 180 minus 69, which will give us 111 degrees. So that is how we can be able to use parallel lines and the transversal to be able to solve problems arising from such cases. So that brings us to the end of our discussion. In our next lesson, we shall cover quadrilaterals and other polygons. Thank you.